Okay, good afternoon, everybody. Please kindly confirm that you can hear me loud and clear.
Yeah, we can hear you loud and clear. I can hear you.
Yeah, loud and clear.
I can hear you.
Loud and clear.
All right, okay, good afternoon, everybody. Or I would say good morning, good afternoon, good evening from anywhere that you might be joining us from. I welcome everybody to this afternoon's class. So my name is Oladapo Babalola, and I am one of the co-founders of DevOps as a Service Nigeria, also known as daas.ng. And it's a free DevOps mentorship platform to mentor what we call the next generation DevOps practitioners that will learn, innovate, and disrupt their various IT spaces, with the DevOps culture, skills, and the understanding needed to thrive in the modern workplace, right? And so once again, on behalf of my colleagues, my co-founders, Oluwaseun Oyetoyinbo and Nuruddin Kamilu, I welcome you all. Yeah, so today we're going to be looking at Docker. We're going to be looking at Docker. So let me just stop my video. Okay, right. Okay, so let me just share my screen. All right, please kindly confirm that you can see my screen.
Yeah, I can see your screen.
Okay, yeah, so just like I've said, today we're going to be looking at Docker, right? So what is Docker? I'm sure so many people would have, heard the word Docker, and there have been so many misinterpretations about Docker. Some will say that Docker is a container or a container is a Docker. So briefly, Docker is just a software, or it can also be called a framework, and it's used for building, running, and managing containers on servers and on the cloud. I'll repeat myself. So Docker is a framework or is a software for building, running, and managing containers on the servers on the cloud. So don't worry about the word containers. Would get to the meaning of containers as time goes on. So, but how did we get here? What has been the evolution? What have people been using before now? Why do I need Docker? Why don't I just use a virtual machine, or I should just go to the cloud to deploy my application and then it will run, right? So before that, let us go on a little trip to, learn more about virtual machines, right? So virtual machines, as we call it, some will actually call it VMs, right? They run on a physical machine using what we call a hypervisor. VMs, they run on a physical machine, right? And before those VMs can actually operate on the physical machine itself, they need to run on another software or another firmware called a hypervisor, right? So let me just give, can you confirm that I can see my screen? Can you see the yellow page?
Sir. Yeah.
Okay, cool. Now, virtual machines, let me illustrate this as 3 virtual machines. As we all know, these are the 3 virtual machines, right? They run on something called an hypervisor. And this is an hypervisor over here. Call it H. Now, this hypervisor in turn run on a physical server that you can see, and touch. This is the physical server itself. So what this means is that once I buy this server newly, right, in front of that server, there is usually a slot where you can insert a disk into it. Once you insert that disk, right, what you're trying to tell the server is, please spin up or install a hypervisor software for me. So after installing that, you have what we call an hypervisor here. An example of an hypervisor is VMware. On that hypervisor, you install your VMs. And what are the content of the VMs? You have your OS, which is the operating system. It could be Linux, it could be Windows, right? You have binaries and libraries over here. And then lastly, you have the application that you want to run on the VM itself. So the same thing applies to the remaining VMs over here, right? Now, it means that each copy of a VM that you have here would include an operating system, the binaries and the libraries. You can actually call it binaries or libraries, and then the application itself, that will run. So for this app to run, you can see the number of things I would have to install. I would have a physical server. I will have a hypervisor, because without this hypervisor, then it means that it's only one application that I can run on this physical server. But with the hypervisor, it has done abstraction of the different CPU, storage, RAM, and what have you. It has now abstracted it to these individual servers that we have here so that they can run on their own. Right? But this is what we have traditionally. But what is the disadvantage of this? Now, the disadvantage of this is that utilization is usually very high, meaning you can have this VM consuming as high as the maximum allocation has been allocated to this physical server itself. So you have high utilization. Then you have the size of the VM itself, which is usually very huge. Now, at the end of the day, the size of this VM can go as high as 200 gig. Just because I want to run few applications, I'm having 200 gig, right? Then another issue is it takes longer time for this VM to boot up. Sometimes it can take 30 minutes to 1 hour, right? I battled with the server before that. The server took 1 hour to boot up because it was installing multiple patches. And then what will now happen to my customers? My customers would have to wait for this VM to come back up for me to now, continue the normal processes. Now, these are the advantages, right? And then the good guys at Google, right, now came up and said that, man, guys, we are tired. We can't continue to use this architecture. Then they now came up with another architecture. And with that, let me draw a new, that was how, containers were bettered. Now, what is now the infrastructure? These are the containers. Note that containers works similarly to a VM, but there are so many differences. These are my containers. These are my containers over here, right? Now, this container, instead of the containers to run on a hypervisor, they will run on something that we'll call a container engine. I'll name it CE, a container engine. And this container engine would, of course, run on a server that has an operating system. And of course, that is running on a host machine or on a physical infrastructure itself. Now, what is the difference? The difference here is instead of installing OS on all of these guys here, the only thing I just need to have within my containers here is just two things. I need to have my application and my binaries. My binaries or my libraries. You can see that the need for having an OS has been removed. The same thing happens here, right? I have my application and I have my binaries. Same thing applies to this container over here. Now, what is the advantage of this, right? Utilization is not high. Utilization is very, very low. The size is not in gig. The size is usually in few megabytes. You can have a container as low as 50 MB, running and serving, thousands of requests. That's how light this container is. And then the last one is it takes lesser time to boot up compared to when I have to wait for 30 minutes or 1 hour for my VM to boot up. Right, this container would boot up in less than 20 seconds, less than a minute. We're going to demonstrate all of this as time goes on. So I just need to illustrate the reason why we are doing what we are doing, or the reason why we have Docker containers. Do you understand? Now, what are the popular container providers? Right now, that is where the concept of Docker now comes in. So Docker is a popular container providers. Okay, please, if you have question, would hold on for now. I'll give room for questions as time goes on. Okay, now, what are the popular container providers? Number one is Docker. So whenever you hear Docker, you can see why Docker is not a container. Docker is just an engine that enables container to run. So Docker, right, is number one. Number two, we have Rockets. It's being spelled RKT, but you can actually pronounce it as Rockets, right? That is another container provider. Then we have CRIO. That is another popular container container provider or container engine that Kubernetes uses. Right now, what are the popular hypervisor providers? You know, we have VMware, we have Hyper-V, we have Oracle Workstation. All right. Now, once we have that understanding, let us now go into Docker itself. So I'll give room for questions now. If you have questions, please kindly unmute and ask.
Okay, just looking at the architecture you drew for both of them for the containerization and the virtualization aspect of it. So for the first one, which was the virtualization, if I have a hardware where I store a hypervisor to virtualize the environment and then I start installing physical servers on top of it. So can't I still do the same thing and have a container engine put on top of the hypervisor and start having my application on them?
Okay, yeah, good question. A container engine will always run on an OS. It can't run plainly on an hypervisor unless some managed instances like VMware Tanzu. I think you can actually go online and read about VMware Tanzu. So that is like the container technology for VMware itself, right? So that is still possible, but it means what they're actually buying itself is you have a server, right? And then you are buying a software that has an hypervisor and has the container engine installed for you. So you may need to read about VMware Tanzu. Let me just VMware Tanzu. That should be able to answer your question. So VMware Tanzu is by VMware, and instead of installing an hypervisor separately, you can just purchase the Tanzu software and you'll be good to go. So it will still be the same architecture that we have here, right? You have the physical server. Then instead of installing your OS and installing the container engine, what you just need to do is just to plug in the VMware Tanzu ISO image or DIX or whatever you're giving. And then this guy is just going to install everything that you need to run containers. Does that help?
Yes, it does. Thanks.
All right. Okay. So let's go on. So now we're going to be talking about installation of Docker itself, Docker engine. Well, I won't be doing the installation. It's just an easy process of installing Docker. And again, Nuruddin and Sheon will always talk about, documentation. Anything you are doing, Terraform, Ansible, there are so many documentations that you need, right? And you must not cram all of the techniques that are being used there, but instead understand what it is they do, and then always go back to the documentation itself. So this is the Docker documentation, very, very large and elaborate. It's docs.docker.com. Now, if you want to install Docker on your Ubuntu server, right, you can always install Docker on Ubuntu, on CentOS, Red Hat, and what have you. But because Ubuntu is pretty straightforward, just go to docs.docker.com/engine/Docker /install, or just go to Google and type how to install Docker on Ubuntu, right? It will bring you to this page. Now, what do we have here? They are telling you that these are the OS requirements. To install Docker, you need 64-bit version of one of these, meaning the server that you want to install Docker on must be 64-bit version, else it won't work, right? And these are the different Ubuntu Bionic, Focal, Impish, Jammy, and what have you. And these are just go through the installation method. It's pretty straightforward. You need to update your server, install some certificates, add the official GPG key. So this GPG key is just for, security purpose, and all. But what it does need to do is just to copy all of this and then slam it on your terminal, and it'll be good to go, right? Then you can, install the Docker engine and all. But if you don't want to go through all of these processes, right, just scroll all the way down, and then you can use what we call a convenience script, telling you that instead of going through all of these processes, you can just use the Docker convenience script and just run these 2 commands, and you have Docker installed on your machine. You'll be good to go, right? So what this command is just doing is that it is downloading this get.docker.sh, and then you're having a dry run, which is now implementing all of the processes that's within this shell script itself. Then you'll be good to go. But if you want to try Docker without installing anything, right, you can just go to Docker Playground. You can actually launch your own instance, even as we are here. Play with Docker, right? You will need to log in because I've already logged into Docker Hub here. That's why it has authenticated me automatically. So just play with Docker, right? Click on Start. And you don't need to install Docker. You don't need to install anything. What it does need to do is you have 3 hours, okay, 3 hours, 59 minutes to play around with Docker. Just add a new instance. And here you go. You'll be good to go. And you can now start playing around with Docker. All right. So that being said, let us go further by talking about 3 important concepts. Very, very important. Docker file, Docker images, and Docker engine. Remember where we are coming from, right? We have already installed the container engine. Let us assume that we already installed the container engine. We now need to start, creating containers. We need to start creating containers. Now we need 3 things for our application to run. We need a Docker file, we need Docker images, and Docker containers. Now, for you to better understand this, because this can be very, very confusing, but for you to better understand it, let me just paint a simple scenario. I want to build a house. What do I need before building that house? Can anybody just tell me? I want to build a house. What do you think is the first thing I need before building that house? So this class is going to be very, very interactive. So guys,
You need a house.
You need a plan, house plan.
You need a plan now, a land. You need to get a land.
great. Someone said I will need an architect. Yeah, great, good. So the first thing I would need, please follow me. The first thing I will need if I want to build a house is I will need an architect or an engineer. Okay, I will need an architect and an engineer. And what would that architect do? The architect would design and give me the specifications needed to build that house. Specifications like, the architect would, plan the house. It would draw the architectural design of the house. The engineer would tell me the materials needed, sand, cement, and the quantity needed, including how I'm going to mix the sand, cement, and all of this. All of this information will be written in a document, right? Or a book. Now, see that document as a Docker file. See that document as a Docker file, right? Next, these documents that has been written by the architect and the engineer would need to be interpreted by someone called the contractor, who is now the person that will now go and get the artisans and then they will build the house according to specification in that file or in that book. Anything outside that document is considered null and void, and it's not valid. So within that document itself, the architect has said that we'll be needing 20 windows. We'll be needing 20 windows. And then the contractor will now come and say, no, it's not possible. I will only do 30 windows for you so that I can have fresh air. At the end of the day, the contractor can actually be arrested because he didn't follow the specifications in that file. Do you understand? Now, the contractor now goes ahead to build the house. Now, after that house has been built, see that house as a Docker image, right? The house has been built, see that house as a Docker image. Now, but the owner of the house needs to move inside the house with his family and his relatives. So what would they need? They will need electricity. They will need things like water supply. They will need things like gas. By the time all of these things are running, then what that means is that the house is ready to be moved into. Now, see that house that's been ready to move into it as a container. Am I making sense?
Yes. You're making sense.
Good. So again, I'll repeat myself. The architect needs to build a house. The owner of the house needs to build a house. It goes to the architect. The architect, comes up with the architectural design, gives it to the engineer. Engineer talks about the materials needed, cement, what have you, gravels, and all. They document all of those things. Now, that document, see it as a Docker file. Next up, they give that document to the contractor who now builds that house according to the specifications in that file, right? After that house has been built, see the house as a what? As a Docker image. The owner needs to move inside with his family and his relatives. He can't just move into the house without light, without electricity, water supply. Now, he gets the maybe interior decorator, to design the house. He gets a plumber. He gets whoever that is needed to be able to supply things like water, gas and all. Now, once that house is running, quote and unquote, running, then it means then just see that running house as a container. So the Docker file is the build instructions needed to build a house, the operations, needed to do that thing itself. So Docker file, Docker images or Docker container images and Docker containers are what we'll be looking at. Now, once you're able to grasp the concepts, then you'll be good to go. So let us start with Docker image. Let us examine the content of a Docker file. Do we have any questions thus far? Okay, since there's no question. Now, I'm a developer, right? I want to build a web app that would run on a server somewhere, for users to be able to consume and see and all. Right. In this tutorial, we're going to be looking at Express app that runs on Node and Node.js. I think that is the programming language that I'm actually very, very familiar with, Node applications and .NET Core applications. So I will just show you what I need to do. Okay, so now this is my Express app. Now, this is a very simple app that I need to build and deploy on a particular server or deploy on the Docker containers itself. If you are very familiar with Node or if you are very familiar with Node.js, now this is something that a developer will do on his PC manually. The developer is the one that is writing and building this particular code by himself. He has not involved the testers and the DevOps practitioners. It's just building and testing. And this is how the the developer will do it. Now, inside this folder, I have two documents, which is my package.json and my server.js. Don't worry yourself about this. We're just trying to kind of like build an application. Now, what is inside my package.json? This just has, metadata of what it is that I want to build. So, for example, I can just change the name of the app to, let's say, Dapo app. The description, this daas live class, and then the author. So you can see that this is just like a metadata, the information of my app itself. The author is my name. Then I'm just informing Node that this is where the main application is itself, server.js. You can see I'm just pointing to server.js itself, and then the dependencies and all. But don't worry yourself about what we have here. So let me just save this file, and then let me open the server.js here to see what is there. This is just a simple Express app, that just prints, hello, welcome to Docker class. Do you understand? And it's exposed on port 8080. Forget about the remaining things. Just know that this app, by the time it gets to production, is going to be exposed on port 8080, and it will print, hello, welcome to Docker class. Am I making sense? Now, what the developer will do after, writing his code, the developer has written his code, he wants to build this application on his system. What is he going to do? He will just launch a CMD, or if he has Visual Studio Code, you can do all of this inside. Right. Let me just confirm the version of Node I have. You can see that Node is running on this system. Right. Let me confirm the version of NPM. NPM is running here. So if you are wondering what is Node, what is NPM? Well, the Node is just a platform that is used to build scalable applications. That is just all. While the NPM itself is a software, that needs to be installed to build Node applications. So NPM and the Node, they actually depend on each other to be able to build web applications. Do you understand? So I've installed my Node and I've installed NPM, and I can confirm that the both of them are running. Right. So how do I build this application? Please just take a look at this folder, because this information is needed when we get to CI/CD. Because you have your CI, which is your continuous integration part, which has a build server. So this system can be seen as a build server. And how do I build this application? Because I can't do anything with this application because it has not been built. They are just in the raw formats. I just finished writing my metadata and the application itself. How do I host this application? Now, in Node, the simple command to run is just npm install. That's all. Now, please, as I'm running this, take a look at this folder. You see what will happen. Can you see what has happened? Before now, I had just package.json and I had my server.js. Do you get? It means that based on the specifications that I had within my package.json, because I told Node that please, before you run my application, go and download all the dependencies needed. Right? Go and download all the dependencies needed, and these are all of the dependencies. You can see them. These are all of the dependencies. And then together with that, it created a file called package.lock.json. Do you get? Now, based on this, I just need to run one more command, node server.js. Once I run this command, right, it would launch, it would automatically deploy my application, and I'll be good to go. Enter. You can see it's telling me that this application is running on port 8080 on my system. So let us go to port 8080. So localhost port, sorry. You can see, hello, welcome to Docker class. That's just a simple analogy. I've now built
I hear you clearly. The thing is breaking.
Oh, sorry, can anybody hear me?
I can hear you clearly. I think it's your network.
I think it's
I
fine.
can hear
Over.
you clearly, bro. I think it's a network.
I think it's his network. Go ahead.
Okay.
Go ahead.
Okay, please kindly check your network. All right. So it means I've actually deployed this and I'm good to go. You can see localhost.8080. If I should exit out of this and refresh, my Express app is gone. So let us change some other information. You can see that I am hosting this on port 80. What if I want to change the port and host it on port 9090? And then I want to change the message over here. Hello, welcome to Docker class. Hope the class has been interesting. Right, I save this guy, and then I run the node server.js. Then I come back here and refresh. Oh, sorry, port 9090. Can see? Hello, welcome to Docker class. Hope the class has been interesting. So this is what a developer would always do. So is modifying his scripts, testing the scripts to ensure that it's actually doing what it ought to do. So all of this repetition, it means that the developer is actually testing this app on his own. So what if I have actually finished, or the developer has actually finished testing, he has finished all of these things. He hands over these files. Let me just go back. He hands over these files that has finished building. He hands over this file, packages, hands this over to the tester. The tester will now deploy this on his own platform and then do some other testing to ensure that, okay, based on the specifications by the project manager says that the output of this application must read, hello, welcome to Docker class. But based on my testing, I'm saying, hello, welcome to Docker class. Hope this class has been interesting. Do you know what the tester will do? The tester will repackage all this thing and then send it back to the developer that, okay, this thing is not according to specification. Right? Now, developer starts again, edit everything. And then at the end of the day, he was able to correct what the tester actually sent to him. Well, this time, maybe he now missed out something. Instead of the original hello, welcome to Docker class, right? He now had hello, welcome to Docker class, hope. He gets to the tester. The tester now misses that thing again and say, oh, okay, based on what you have done, right? It has been corrected. It now gets to the DevOps practitioner. The DevOps practitioner has that confidence that because the tester has tested, this thing needs to go to staging or it needs to go to production. By the time it gets to production, customers are now saying, hello, welcome to Docker class, hope. Do you know what will happen? They will now revert to the initial running version that they have, send it back to the developer. The developer will now start work all over again. That was how DevOps came across. That instead of all of the mistakes that the tester, did, right? You have a pipeline that is doing all of these checks automatically. So the only thing that the developer would have to do is just to correct what we have here. By the time you correct this thing and saves it, the pipeline would kick off automatically. It will do all of this manual processing that I've done. It will do all of this building in npm install and then Node.js. It will do all of this thing automatically. The testing the tester does not need to do any manual testing based on the concept of continuous testing. That thing is testing to ensure that this is the final output of, this is the, the required information. By the time it now gets to the continuous delivery end, for it to be delivered to that environment, right? It will just be delivered or deployed on the target environment automatically. That is the concept of DevOps. DevOps is no more than this. So once you're able to get this concept, right? But for us to be able to achieve this, we need to run, microservices within Docker, right? So let us now go ahead and build the Docker image. I just need to kind of like stress on this very well so that you understand the concept of what it is that we are doing. Okay, good. So let us now go ahead and build the Docker file. Remember that these are the processes: npm install, node server.js, and then we have our package.json and our packet log.json. And then remember that this was exposed on a particular port 1990, or let me just change it back to 8080. So DevOps is all about automation. You are automating all of these manual things that I'm doing. You are automating them to make it seamless. That is what DevOps is all about. You are automating end to end. So, but for me to be able to automate this, I will need to specify my Docker file itself. Remember, Docker file is the specifications of how I want my house to be built. So let's go ahead and create a Docker file. Okay, so within this same, what is it called now that I have? Within the same space that I have, I will create a Docker file. Now, how do I create a Docker file? Just like the name in nice. Just going to be Docker file. That's all. That is everything that you need to do. So in that Docker file, let us now go ahead to start populating the Docker file itself. Now, this is very, very important. Please take notes. Now, Docker file can be complicated. It can be complex. Your Docker file can be different from the Docker file of your friend. It can be different from the Docker file of another person. But the most important thing is that you must have to be able to optimize the Docker file so that it doesn't do so many things. It doesn't, download things that are not meant to download. So let's go ahead. Let's go ahead. Just a minute. Okay, so what is the first thing I need to do? Remember, before I was able to run this node, before I was able to run all of these commands, I had to install Node on my system. I had to install Node on my system. So let us now, that was the first thing I need to do. So with that, I can now start my Docker file by saying, I want a base image. Now that base image must have Node based on what the people that actually deployed Node has done. I will repeat myself. Instead of installing Node again, within my Docker, my Docker architecture itself, or within my container itself, I want to rely on the existing Node installation that we have already. Let me just give you an example of what I'm trying to say. There is Node as an image already. Let me say Node images. You can see there's a Node image already. Now, what that means is that we can always leverage on existing images. So we don't need to, start installing Node again. That is what I want to specify within my Docker file here. So I'm saying that the application I want to build here must have Node running, but I don't want to install Node. I want to leverage on the existing Node image that we have running already. official node image that we have within Docker Hub. So with that, I want to leverage on Node, right? So I can now go ahead to say that I want to build my application from Node. That is the first line. You must always start your Docker file with a from, like where do you want to build from? Do you want to build from scratch? Do you want to build from something? Now say, I want to build from Node, right? And then Node works. There are different versions. Let me show you the version on my system. Okay, I think I actually showed you the version already. Node version is 16. So by adventure, I want to build my own from Node 18. That is what it's there. By adventure, I want to build my own from Node 16. I'll just specify 16 here. Next line. Once that is done, right? I now want to create a folder, something like this that you have. I actually created a folder called Express App. I'm now saying that based on that image that I want to build, I want to create a folder called, it could be anything. It could be Express App. It could be my name. It could be anything. So we now say that next thing, I want to create a folder. And how do you create a folder inside that email that we're going to build? You just type work directory, meaning I want the working directory to be in this part. I can use usr/src/app. This can be anything. It can be maybe user, maybe home /darkboard, maybe anything. But I'm using usr/src/app, meaning once I want to start building this image itself, I need a directory called usr/src/app to be created inside the image. Right? Now, what is now the next thing? Before we move on, remember that when I ran this command, when I ran npm install, this npm install, right, is looking for this package.json, right? Docker would also need this package lock.json for you to run. So before I tell this Docker file to run npm install, I need to copy these two files into this directory here. Now, what this means is that once I define this work directory is like I'm doing a CD into this place here on Linux. So once I'm able to do the CD here, it means I'm within this app directory, and then I can now start running my commands, right? So now I now want to copy the package.json into this particular directory. How do I do that? You just copy package, right? What is the name of the file? You can see package.json and package.log.json. So if I need to do this, I can just specify that package.json. So what this means is that I am copying everything. I'm copying package. I'm copying anything that starts with package, including .lock. I'm copying everything to this working directory here. Am I making sense?
Yes, you have.
Yes, you are.
Okay, good. So I'm copying this to the present working directory. So this means the present working directory, which is this. I can still decide to still put it here like this. It's still the same thing. I can still decide to put it there. It's still the same thing. But let me just leave it as it is like this. Now, what is now the next thing I need to do? I will now run npm install. As I did here, you can see I ran npm install. That is still the same thing that I'm doing inside the image. Do you understand? Mind you, this, because I'm still inside the work directory, this npm install will be run within where we have my package and my package.json. My package dash, I don't know why that thing is, package.log.json and then package.json. So as it is like this, it means inside my Docker, my Docker image, I have something like this, USR. Let me just put the slash like this, right? So this is what I've just done. I've copied this and this inside this particular directory, and then I can now run CMD. I can now run npm install. Do you understand? This is the manual process, but I want to do this inside the Docker image itself. So all of these things is what Docker will do, right? So what will now be the next thing? The next thing now is, as it is like this, I have only installed a dependency, which is Node. But what will Node do? Node would have to act on the application itself, which is this server.js. It will act on this application. Once I just move it here and then run my, what's it called, node server.js, that application will be deployed automatically. So the next thing I have to do here is to copy this server.js inside the image. Now, how do I do that? How do I do that? I would say, Mr. Image, once you have done all of these things, right? Copy every other thing, meaning, let me just delete this two, or let me just delete this two. So this is a stage I am Abi. I've run npm install. I will now tell the image that copy every other thing, like copy every other thing, because I've already copied package.json and package.log.json into this folder within the image itself. And I just want to say, okay, copy the last one, which is server.js. You can also have some other dependencies. Copy every other thing into this folder so that we can move on. Now, that will now be, I'm saying copy everything within the directory that we have, where we have, the source code. Copy everything, notify it as dots, right? Copy it to this present working directory. You can see that when I press my space, it's telling me that your present working directory is this. So it's either I choose this or I just include a dot. That's all. It means it's copying every other thing to that folder itself. Now, what is the next thing I need to do? I need to inform the image that once you have copied everything, and before you start running the application, expose port 8080 as I have defined here. You can see I define port 8080 in the application itself. So the image itself, you are telling the image that, Oga, please, before you do anything, expose port 8080, because if you don't expose port 8080, there's no how the application can run. So I'm exposing port 8080. And then the last thing is this command. This command that I ran. For it to run, that's for the application to run, I ran what? Node server.js. So that will be the next thing I will run. And how do I do that? Because I ran it within the command prompt, right? You have to specify the command to run as well. Then include it in an array. Don't worry about the word array, but then include it in an array, just the way I'm doing it. And then specify the first command, which is node, comma, because I want to run two applications, because I want to run two commands. I need to separate them, within a comma and a parenthesis. So server.js. That is what I did here. That is all. That is the instructions. You can see that this is like the architect or the engineer giving the contractor all of the instructions to do. So let us quickly go through this, because once you get this, then you'll be good to go to understand anything that you want to do. So, okay. So I said from node 16, I want a base image that has these two guys installed, that has node and npm installed. I have gotten it here. I now created a work directory. That what directory do I want to do all of this? What directory do I want to run all of these instructions? I now specify that I want to run within this particular directory, work directory. Now, once I type work directory with the directory part itself, it's just like say I'm going into CD. You can see it's like I'm changing my directory to another place itself. That is what this work directory is doing. So by the time I type work directory to the part itself, it takes me to that part. So once I'm inside that part, right, I'm now copying the package.json and all of the files into, by the time I put copy, right, it's now going outside where I am, outside the image, to copy all of the dependencies, to copy it to this work directory that I've created. And then within this work directory, this run will not run outside. It will run inside the container within this work directory. It will run npm install and then copy the other things, export post8080 and run node.server.js. But there's an issue. Now, what is that issue? That issue is this. Remember that when I ran this manually, it created some funny stuff here, node_modus. This is not really needed, or it will be too heavy when the Docker container is running itself. Remember that the end goal is for us to have our Docker image, built as a very lightweight application itself. So I don't need all of these things here. I can exclude it. And that brings me to another concept called Docker ignore file. I want to ignore all of these things. I want to ignore it, meaning once Docker runs all of these commands, automatically it's going to download node modus. But I don't want this node modus because this modus is too huge for me. I don't want to ignore it. So your Docker ignore file, right, is a file informing Docker that please, anything that you see within this file itself, ignore it. I don't need it. So you can now create your Docker ignore file. And how do you create a Docker ignore file? It's just .docker, just like the name signifies, Docker ignore. That's all. Then what can I now specify within the Docker ignore? I want to ignore node modus here, node_modus. I just type node_modus. That's all. And then if you have some other log files, that you want to just specify them here, and you'll be good to go. So, have I made sense thus far, or have ended up confusing someone?
Somehow.
No, you've actually done a very good job. Thank you for this. Well, my question is, I've seen people use entry point and CMD interchangeably. Is there any difference?
Okay, yes. Concept of entry point, yes. I'll come to you. Concept of entry points and CMD is they perform similar functions. So now, I don't want to, okay, let me just explain the concepts. Now, what you have within your entry points, once you start running your containers, of course, you have, Docker run, and then the name of the image, which we still get to, right? Now, let's now say that within my file over here, within my file over here, I have a command. I have a command called, let's say, I need this guy to run sleep 30, meaning this application will sleep for 30 seconds. Do you understand? Now, what I don't need to do is just to include this within my Docker file and then create what we call an entry point this way. An entry point. Same thing. And then I include sleep, then dot sleep 30. Do you understand? This will still do what it needs to do, but there will be an issue. And that issue is if I should run my Docker run, which I'm still going to get to. That's why I don't want to kind of like answer the question now because it might actually confuse some people. If I now want to run the container and I type Docker run, right? Now, once I run that container, the first thing that's going to run is it sleep 30 within the application itself. But if I need to type Docker run, maybe the name of the image, and then I specify the Docker image. Let's say the Docker image is Docker image. And then I now want to overwrite this 30 that is here. I don't need to type, okay, let me say sleep. I want to overwrite this sleep 30. I'll just type sleep 40. This is going to overwrite everything that is within the entry points. But if I want to type sleep 40, I only want to specify the variable itself, right? This variable can now be defined within the command here. Oh, sorry. I think it was my network. Let me share the screen again. Can you see my screen?
Yes.
Yes, yes.
Yes.
Okay. So if I type Docker run, the name of the container could be anything. Then I now specify the image and then type 40, right? What this will happen is that it will now go back to the entry points and just run sleep 40 automatically by ignoring 30. But if I want to be interchanging, or if I want this to be a variable, I want I want to type sleep 100, sleep 200, right? I just need to specify that within the command over here, maybe 200. And once I just run my Docker run this way, it's going to implement sleep 200 automatically. But if I come here and type 500 alone, it will go to the entry points and implement sleep 500. It will override everything that you have within the command itself. So the entry point is like you are telling the Docker container itself that, bros, your entry point, meaning the command that you are going to run, should be within this entry point. And what is that command? The command is sleep. What are you sleeping? You are doing sleep 200, meaning this server is going to sleep for 200 seconds. If you now want to overwrite this 200 seconds that is here, you want to type that by yourself when you are running, right? You can just, put in the value here. It means this is going to now go to the Docker image, check for the entry point. What is the entry point? Sleep. It will now run sleep 1000, overwriting the command that you have here. But if you should remove the 1000, what will run? Sleep 200 is what is going to be run. Do you understand?
Yeah, yes, I get you. Thank you very much. But my
question
is, instead of you using CMD, can you just use entry point to call the Node.js?
Yes.
Okay.
So you can use entry point as well. Yep.
Yeah. Thanks a lot.
All right. Do you have any other question? Bolaji Adetoye, please, you can ask your question.
Yeah, thank you so much. Please, sorry to take you back. Where you have the copy ... what does that do?
Yes, so the copy ... is copying your source files, is copying everything in your source files to your destination part itself. And what's the destination part? Is this part that I've defined here. Because I've said that my working directory within the image is this. So by the time you do copy ... it's copying everything within your source folder that you have here. This is my source folder where I have my my package.json and server.js. It would copy everything here, right? It will copy everything to this working directory that we have here. Because within the image, I've said that my present working directory is this. Copy it to that directory itself. So copy ... will copy everything within the source to the destination itself. Does that help?
Okay, thank you.
Okay, cool. So moving on. Now, once you, please, but you will need to read more on Docker files itself. Like, I believe that's like the building block of anything that you want to do within containers. Even before you even get to Kubernetes, once you miss this part, you will also realize that your images, would just be growing. So please try as much as possible to be able to read more on Docker files. But once you get this terminology, once you see any Docker file, you'll be able to interpret it immediately. All right, so let's move on to the hands-on itself. I've used like an hour just to kind of like explain, the concept, which I think was very, very necessary. Okay, so let us go on to the hands-on now. I've been able to copy these files. I've been able to copy these files to the Linux environment that we have that has Docker running itself. So what do I have within this Express app? I have the Docker file, I have the package.json, and I have the package log.json, and then server.js. That is everything that I have here. So I need to now build. Remember now, we now want to start building the house. We need to start building the house. How do I build this itself? It's just a very simple instruction. It's just a very simple command. Now, anything that I'm doing in Docker would have to start with Docker. Do you understand? We have to start with Docker. So let's go. Docker build. Now, I've told the, what is it called? I've told the contractor, please, this is specifications. Build this house according to the specification. And what is the specification? The Docker file, right? But before I include the Docker file, meaning I'm saying that Docker, please build this house according to this Docker file that is here. Now, before I do that, I want to explain tagging, what it does. Tagging is just, you want to name your image. So after you finish building that house, you want to name that house, maybe after your grandmother. Do you understand? So how do I do it here? How do I do it within Docker? Within Docker, we use the tag concept. So when you are tagging, you are naming that image that you want to build. Remember, you've not built it, you want to build it. So you specify by -t, right? And the name. So the name could be anything. So I'll just put my name, maybe Dapo, and then put a /. This / is not really necessary, but I'm going to explain why I'm doing that. Now, I'm tagging it Dapo /. What is the use of this app? Naming convention is very, very appropriate within Docker, right? Now, Dapo is the name of the tag, but then I want to be very specific again. What will this Express app be used for? And I want to, because I want to deploy to production, I can now name it as production web app, right? And then run these dots. Now, this dot is saying that Docker, please build all of the specifications in this Docker file. By the time I put dots at the end, Docker will automatically go to this same folder. Let me just So remember, I am inside this folder and I'm running this command. Docker build. I'm tagging it. That is, I'm naming it to my name / the function of that app. Then I am now telling Docker that where are you going to get the file? Look at what will happen if I don't specify anything here. Do you see? Docker build requires exactly one argument because the contractor, you're not telling the contractor, go and build a house. The contractor does not have the specification. So I need to specify the specification by just clicking, adding a dot file. So it will go within this directory that we have, pick this Docker file and then build to specification. Now, what is inside the Docker file? It's still the same thing that has been done. So let me cut the Docker file. You can see it's still the same thing that I explained. Do you understand? So let's just go ahead and now build it.
Sorry, someone asked that what's the essence of the environment in the Docker file in the chat group?
Okay. The environment, what environment are you talking about?
No, actually, I was asking this screen I'm seeing where you are running the command. Which environment is it? Where are you running it from? I just want to know.
I'm running in within a Linux environment. Oh, remember, I can also do all of this I'm doing here as I showed you initially. You can use, a free Docker instance. But because I have a lab already, because I have a server within my environment, that is why I can actually run. In fact, this is actually a Kubernetes instance because it has Docker running in it. That's why I actually want to leverage it. But all of this I'm doing, you can always do it here as well. What do you need to do? Just click on add a new instance. It will create a server for you within 5 seconds. Then if you now have the applications that you want to run, right, you can just import it. Click on editor. I'm going to send the applications to you guys so that at least you can practice your own. Then you can now upload, create or upload file in the section terminal and refresh. I don't know how to upload. Okay. I don't know how to upload files here though, but you now have to upload file within this particular environment itself, and then you'll be good to go.
All right, thank you.
Let me see how to, I've never used it before, but what file now? Do I need to type it? Okay, I think you need to type it one after the other, then you save it, reload. Let me see what is here. But you can also figure out how to copy files. Let me see, open editor. Okay, roots. Okay, it has created a file called roots. So what is inside cat roots? You can see. So it's just for you to kind of like figure out, once I send the files to you, right, just figure out how to be able to create different files here. But mind you that after 3 hours, right, this server is going to be deleted. So this is more like a practice environment for you. Do you understand? Then I think we'll be
okay.
Okay, but because
can someone have a permanent environment to practice this?
Yes, of course. You can launch instances on AWS and Azure. We have taken classes on AWS and Azure. You can go back to our videos on our YouTube page to go and at least watch how to create instances. So you can create free server, just like I have here. This server is running on Azure. Do you understand? So I just connected to it from here itself. Okay. So you can create instances on AWS and Azure, install Docker, just the way I showed you. Go to Docker documentation, install Docker, and then practice all of these processes, and you'll be good to go. There won't be any difference. So now let us now build this app. So I'll build this app right now. Click on enter, and then you can see this guy has finished building. Guys, it took like less than how many minutes? 20 minutes, 1 hour. It has finished building.
2 seconds.
Yes, maybe like 2 or 3 seconds that actually finished building. Do you understand? But because I've already run this, because I ran this, I think day before yesterday, thereabouts, it uses the concept of caching for me. So once you build your image for the very first time, it can take less than a minute. By the time you now rebuild it again, it will take less than 2 seconds, as you can see. Now, this has been built. You can see successfully built. It created an alphanumeric ID for me, which I'm going to talk about right now. Then it now tagged it. You can see successfully built this, and then it tagged it Dapo production web, and then attached latest. But guys, I didn't inform Docker that it should attach a version. Now, whenever you see this semicolon, it means this is the version that has been created, the latest version, because I didn't include any version. I didn't include any version in it. It just went ahead to create the latest and then attach it as latest. So how do I do this? How do I include a version? Let me just go back and then put a semicolon and maybe put version 1.1. That is all. So it has built and it has tagged it as Dapo prod web column 1.1 version. Do you understand? So now that brings me to this that has been built. It built and saved it within the local repository on this server. Please take notes. It builds this image. It wants to save the image somewhere. It now saved it on a local repository somewhere. Now, this Dapo / the name of the image can be seen as, this is just more like the repository name / the application name itself. Now, let us now view the images that have been built. How do I view it? It's just Docker images. Once you type Docker images and press enter, it will list all of the images on this server. But because I don't want to do that, I want to limit it to just the last 5 images. I'll just include head-5. This is just a Linux command to give me the latest 5 images that were built. Once I press enter, you can see this was the first one I did. You can see repository is telling me that this is a local repository, and I've named that repository as Dapo / prod web. And then look at the tag. Tag is latest. This is the image ID created 2 hours ago. And the size, this is very huge, 915 megabytes. We'll talk about how to reduce this size. You can see when I now tagged it the second time, it gave it what? The tag 1.1. But this is not best practice because my images are saving on this server itself. And now that brings us to the concept of a hub. I will need a hub that once I finish creating the images, remember the images were created from these specifications that we have here, right? After it created the images, it saved it. We tagged it as this name, right? We named it as this name. We tagged it with 1.1. Docker generated a alphanumeric ID just to be able to at least differentiate the different images that we have, created dates, and then the size. Now, I don't want to always create this image on my local repository because as time goes on, this server is going to get filled up and there will be issues. What do I need to do? I need to push this image to a hub that is outside of this server so that my images will be stored on that hub. And what are the different types of hubs we have? We have Docker Hub. We have what is it called now? ACR, which is Azure Container Registry. That is also another hub. We have JFrog, for those that have used JFrog before. All of these are, repositories. Then on AWS, who can tell me the name of the registry on AWS? Anybody?
Amazon registry.
ECR, Elastic Container Registry.
Exactly. So for For AWS or Amazon, we have Amazon ECR, which is Elastic Container Registry. Do you understand? So those are just the best practices that even experts, they miss out. Do you understand? Now, we don't like the way this image is saved on this server. Let us push it to that hub. How do we do it? This is the hub over here. Okay, I have it opened here. This is my hub. Do you understand? The last time I even pushed to a hub was a year ago. You can see the date here, a year ago. So I want to push this image to this Docker hub so that my colleagues can always pull the image and work on that image. So after I finish building this image, my colleagues that now want to run that our Express app, they don't need to go and start building the image again because I already have the image. They don't need to rebuild anything. What it does need to do is just to run this command, node server.js, like within the Docker, and they'll be good to go. So how do I now push to this image? First and foremost, let us create a repository. So you can see this Babalola 05/test node is synonymous to what we have here. You can see dapo/prod web app. So this, you can see this repository that you have here and these repositories, they are the same thing, but one is local and the other one is, public. So within Docker Hub, we have different types of repositories. We have private repositories and public repositories. Private repositories are repositories that you just want to use within your organization. You don't want anybody to be able to use it. While public repositories, anybody can use that image. And that was how we were able to get that node version 16 because it was made public. So let us create a repository for that. I will call that repository. What should we call it? Let's call it prod. Okay, let's call it prod, or let's call it staging instead. Staging web app. I think that is all. Okay, we can target, let's say, version 2.1. So it's either private or public, because I want to make it public for my guys to be able to, pull. So must contain. Okay, let me remove this. Sorry. So this shouldn't, because I was actually following this. I didn't look up. So this should just be the name of the repository, staging web app, and then create. Right. So what would now happen is that let's now push a staging web app to this place here. But before that, let us create another image. That same image, or before that, we can have multiple tags. So one image can have multiple tags, can have multiple names. And how do we do that? It's just still the same command, docker build dapo prod web app 1.1. Then I can have another tag here. Let's say dapo staging web app, right? I can name this, let's say version 2.1. I can have several tags, but let us leave it as 2. So I want to tag this image, meaning this image can be used for both production and for staging environments. So once I build this, and then I run my Docker images again, head 5. You can see what is happening. It has created 2 images, version 2.1, which I defined here, and then version 1.1 that I defined here. Do you understand? You can see that the image is the same thing. Now, let's now assume that I want to push this guy to our Docker hub, right? The first thing you need to do is to log into, log into the Docker hub itself. And how do you do that? You just do Docker login. Type your username. My username is this. So Docker login minus username, and then this, then the password. So I have logged in to my Docker hub. So I now need to, please follow me. This is very, very important. And I need to push this image. I want to push it to my remote hub over here so that my guys can actually use it. Remember, this is the name, Staging Web, Babalola/Staging Web App. Now, this is quite tricky. How do I do this? I will tag it. Remember, tagging is like you are renaming a repository. You are renaming an image. So I'll just do Docker tag. What do I want to push? I want to push this. What version? This version. Right. Where do I want to push to? I want to push to this place here. So I just copy the name. Oops, sorry. So what is the name of the guy again? Right. So what version? The same version.
Please,
so now,
please, can you kind of clear your screen so we can no more.
Okay. Cool. Sorry, let me clear my screen. Okay. Before that, let me do my Docker images. Let me list the Docker images again. Head 5, right? So before I push this image here, I need to rename it to the exact name of the repository that have been created here. Please don't confuse it. I have to rename it. And how do I rename it? By just including a tag statement. So Docker tag, the source, and I'm tagging into the destination. So once I press enter and list the images again, you can see it here. It has renamed it, but I've not pushed. How do I push? I'll just do Docker push. This, what version? Version 2.1. Can you see? It is pushing that image to the central repository. So if you go back and refresh this page, what do we have? Can you see what has happened? This version 2.1 a few seconds ago has been pushed to the Docker hub itself. So by the time this image is here, I can now go back and conveniently delete the image so as to free up space. So how do I delete an image? It's just Docker remove image RMI. Specify the name of the image. No, let me not delete this one because we still, okay, let me delete the older one. Which one can we delete now? Okay, I can still delete this. Remove this image. I don't need it again because it's already on the public hub, and do this. That's all. Okay, so Good. So let us check it again. See, can see it is gone, but I'm still safe because this is here. So some will be saying that because you have deleted it, it will delete here. Nope. Let me refresh it. Can see it's still on the hub. Can you see? Still on the hub. So if I want to now pull it back to the public repository, maybe I want to work on my system. It's just Docker pull. I'm pulling it back. Or I'll come back home. Docker pull. So what am I pulling? I am pulling the same guy. That's all. So let us see. You can see it is back, like it never left. Do you guys understand? Do you understand the concepts?
Yes.
Yes, boss.
Okay,
Yeah.
all right. So let us take a 2 minutes break and just ask questions so that we can round up in like another 10, 15 minutes. So do you have any question before we move on? Remember, the image has been built. So right now, we're at the stage of the engineer has finished building the house, but nothing is running inside the house. There's no water, there's no gas, there's no electricity. That is the state of this image. So this tag is like saying, I want the house to be located inside an estate. So what is the address of that estate? Maybe number 25, Preston Street, Surulere, Lagos. That is what this tag is all about. You are tagging it kind of like, you are giving it a descriptive name of your house, because we can have different houses, the same houses, different places. So, but what differentiates it is just the address. And then the image ID. What date was this house created? It was created 2 hours ago. What is the size of the house? This. So remember, this is just the image. It is not running. So this image can sit here for the next 20 years. It will be as useless as this because it is not doing anything. So let's use 2 minutes to just cool down our brain. Maybe if you want to take water, you can just go and take water. If you want to stretch, you can go and stretch. And then let's come back in 2 minutes and run this image. But if you have any question, you can just ask. But
okay, I have a question.
Okay, please go ahead.
So this tag, is it the same thing as the version? Because I've seen some this thing that they will put like my SQL, and they will put my SQL 5.2, 5.21.
Perfect.
I don't know if it's the same thing as the tag.
You are right. You are right. So the tag is just like the version.
Okay.
Ifeanyi, please go ahead.
Yes, so I just wanted to ask that this Docker file, who composes it, like who builds it, like who writes the Docker file, the developer or the DevOps engineer? Because I was thinking is the DevOps engineer, but then does it mean the DevOps engineer will have to be in loop, like understand every step it takes to actually build the app manually, like the developer does? I want to understand how it goes.
Yes, perfectly. You are right. So the Docker file itself is not written by just one person. It's written by both the developer and the DevOps practitioner. Do you understand? Now, let me tell you what we do presently, because we have several containers, I think hundreds of containers running within our environments. And this is how we do it. Now, if there's a new application that a developer wants to, let's say, for example, this Express app now, right? I usually mandate that any developer that wants to work with my team, they must know how to write Docker files. If you don't know how to write Docker file, you have to go and learn it, right? You have to learn how to write Docker files. You have to learn because all our services, again, is very, very essential that even if you want to Dockerize anything, it must be microservices. Remember that we've done a class on microservices. So because we run a microservices architecture within our environment, mandated all the developers to go and learn Docker. And all our developers today, they know how to use Docker. So the developer would write the Docker file, and then put it in a repository. Once it commits to that repository, we'll get an alert. We'll go and check the Docker file just to ensure that it follows best practices, and then we run the test and build. So it's a collaboration between the developer and the DevOps guys. You understand? Okay. And again, you must also understand how the code works. So don't just say, I'm not a developer, I'm just a DevOps. No, it doesn't work like that. I'm not saying that you should learn coding, like just know how to build. Because right now, I know that if I want to build my Express app, I need to have Node installed, I need to have NPM installed, I need to run, Node and then point it to the name of the application. Simple things like that will help you when you are building your pipelines. Very, very important. So because of that, I was forced to at least take a class on .NET Core, Node, Python, and Java. Do you understand? Just go to YouTube, type how to build all of these applications. You don't need to know, how to write applications. That now brings us to whether DevOps guys are developers. No, but as a DevOps practitioner, you need to understand how the code works. For example, the Express app, once I open it, I saw that, this thing was exposed on port 8080. What am I going to expose within my Docker file? It's that same port 8080 now. I'll be good to go. Or you can ask the developer, please, this is your port. It's listening on what port? Once it gives you that port, include it within your Docker file, and you'll be good to go. All right, Sanusi, please go ahead.
Thank you.
Okay, thank you. Good afternoon. So I want to ask how testers come into this. Do they need to know how Docker and the whole thing work? I mean, for their automation testing, do they need all this?
Well, it will be good for testers, like my testers today. They know all the architecture, right? How Docker works and all of that. But remember, a tester is only testing the container itself. The container is running, and then the tester is now running its regression tests against the running container itself. So it's not bothering with, is the Docker file built this way? By the time the container is running and it can actually see that at least the container is running, it has a way of extracting the source code and, is now able to test whatever it wants to test. But that is too crude. And that is why the concept of automated testing comes in. Meaning within your pipeline, you can include things like Selenium. I don't know if you heard of Selenium before. So Selenium is a automated testing tool. So you include your Selenium within your pipeline, within your build pipeline, to say that after running npm install, right, before taking it to the CD to go and deploy, Selenium, please run all the checks so that report is now sent to the tester. So what the tester does is just chilling and waiting for the report, because he has already built his test plans within Selenium that should run against this Express app that is running. And then it sends him a report. And with that, he's able to see the vulnerability. Another thing again is security. How does the security guys comes in? And that is the concept of I'm sure you have heard of DevSecOps. Now you are actually including security within your pipeline. Security can come in form of integrating with tools like Sonar Cloud, which we use. So Sonar Cloud is a vulnerability scanning tool that actually run within your pipeline. So as all of this is building, as I'm running my npm build, Sonar Cloud is taking that artifact. Now, the end product of any CI is called an artifact. It's taking that artifact and then it's running scanning. It's telling me that all the npm packages, remember that we downloaded packages, are there vulnerabilities in it? It runs all of those cards and then sends the report to the testers. So that is just the concept of DevSecOps. It's just integrating testing into whatever that is being run. Does that answer, Sanusi?
Yes, thank you very much.
Yeah, okay. Mukhtar, please go ahead with your question.
Okay, man, thank you very much so far for the explanation. Actually, this is my first time for joining this live section, and I just want to get some little clarification, like how often do you guys hold this, and how can I get access to this Zoom recording, let's say after this recording? These are just my question, and I really appreciate your time and explanations so far. Thank you.
Yeah, it's fine. Okay, so Bamukta, how did you hear about this platform?
Okay, I'm part of a particular WhatsApp DevOps group, and somebody shared this link in that group, and I joined with the link actually.
Oh, okay, all right. Yeah, so oh, okay. Same with Sanusi. All right. So you guys are welcome. Again, if you didn't join with us, so DAS is just like I think I said at the beginning. So DAS is a free mentorship platform, and we're just here to mention mentor guys, learn from each other. You understand? And we'll be doing this since July. We've been running series of different DevOps principles. We started from Agile, we went to Linux, we went to microservices, Python, a whole lot of things that we've talked about. But if you need our past recordings, you can also go to YouTube and search for DevOps as a service, or just type daas.ng. You'll see all our videos. Yes,
Okay.
DevOps as a service Nigeria, or daas.ng, DAAS.ng. And then
I
you can
think
always
the link on the chat, right?
Yeah. Let me. Okay, is that the link?
Yeah, I think there's a link like that on the chat.
Okay, let me
Okay.
just put the link. Okay, good. Yes, daas.ng on YouTube. Thanks, Bamidele. Daas.ng on YouTube.
Okay.
Right. You see that. Then for the record of today as well, you can just check. Maybe by 9 we would have uploaded this session on YouTube. So please follow us on YouTube and also on LinkedIn as well. Then you can also check our website, daas.ng, to even see what we've done so far. At least you meet with, the co-founders and all. Right. So there will be another cohort in January. So we'll start another cohort in January, and we'll be good to go. So someone is asking, please, is Sonar Cloud different from Sonar Cube? Yeah, you're welcome. So someone is asking, is Sonar Cloud different from Sonar Cube? Yeah. Well, they are the same thing. They perform the same function, but Sonar Cube is used when you want to integrate scanning within your pipeline, within your CI. Remember that we have different continuous integration softwares. What are they? Jenkins, TeamCity, Circle CI, GitLab, what have you. So by the time you want to integrate scanning, security scanning within your build steps itself, that is when you'd use Sonar Cube. But if you want to scan your code repository at rest, you want to scan them at rest, meaning by the time developers commit, right, before they start building, right, you can now integrate the Sonar Cloud. You just integrate a Sonar Cloud with whatever repository that you are building from. For example, if you are building from Bitbucket or you're building from GitHub, just integrate it with the Sonar Cloud. And Sonar Cloud will always scan your repository by the time there is any commit made to that repository. So Sonar Cube is, Sonar Cube is for code coverage and exactly, yes, code quality scanning. Why the Sonar Cloud is where Sonar Cube itself cannot report. Now, Sonar Cube will just do the security scanning of what has been built, and then it now reports it back to Sonar Cloud. Do you understand? For you to be able to see the results. Then if you now want to integrate Sonar Cube, or if you want to integrate security with your code base at rest, that's when you will now integrate Sonar Cloud into it. I think in our subsequent class, before the end of this bootcamp, I will show you how that is done and how to also integrate Sonar scanning into it. All right. Chukwuemeka.
I have a question.
Okay. Israel. Okay, please go ahead, Israel.
Okay. As regard that exposed port, what does it actually mean, that exposed port? Is it where we can access that app, or I will try to map it to another port? But I don't really understand it.
Yes, you are right. Once you want to build a web application, right, you will need that web application to be listening for incoming requests. You understand? So that application will need to be listening on a port. So that port itself is the expose app, or you can also put it this way, that is the port by which you would launch that particular app itself. So now, mind you, if you go to google.com, under the hood, by the time you type google.com, because I was fortunate to be in a Google class, where the Google architects were explaining like the dangerous things that's going, at the background. And I was so shocked. Once you just type google.com, a container is being created automatically for you. Now that container is running on a port, maybe ports 5.2, whatever. But remember that once you type google.com, the google.com itself is not mapping to that particular port itself. That's because what you have in front is just like a load balancer that's done. By the time we get to Kubernetes, would explain all the details to you. Do you understand? So that port that was created is running on a particular port, right? And my request, when I just type google.com, like this, bam, is going to create that container to be run within a random port. If Sanusi should go and type google.com somewhere, another port with another container with another port is created like that. And by the time you are done, by the time you leave Google, that container is destroyed immediately. Do you understand? So that's the concept of microservices, which is very, very, so you guys can just watch, documentaries, watch videos, join seminars all over the world and just learn different concepts itself. Yeah, so that port is where the application is going to be listening, right? But we're not going to show you how to be able to define your own port itself. So mind you, this is very, very important. Let me just, can you see my screen?
Yes.
Okay, we'll be rounding up soon. So let me just explain that concept again. This is you here. You are trying to call google.com, right? Now, google.com application it has its own Docker file, written and exposed on a particular port somewhere. That port can be maybe like port 1990. Port 1990. By the time you type google.com, a container is created automatically. By the time that container is created automatically, that container is created from this image. And the container is given a predefined port. It's given maybe like ports 1000, which we are going to demonstrate right now. To map to this port 1990. So what will happen if Sanusi types google.com as well, right? This container goes to the same image. Remember, a container is a running instance of an image. It goes to this image. It says that Sanusi needs google.com. An image comes up automatically, and another port 2000 is still mapped to that same port 1990. That was the concept. Then at the end of the day, what will now be supplied back to you is just google.com. Just google.com, because this google.com has a DNS service that runs within that has also been integrated with a load balancer, to be able to hide these ports from you. So you don't know. By the time I just type google.com like this, under the hood, right, this can be maybe the container name. Maybe my container name is Dapo, and it's running on maybe like port 6 million. So this is it here. But under the hood, what you just see is google.com. Can see? Once I refresh this guy, the container is being created. You can see the speed. Once I do it like this, the container has been created and it's serving me google.com itself. So that is where the concept of this port comes into play. So you expose the port within the application using your Docker file. And then by the time we start running the containers, which we are going to demonstrate now, you see that different ports, right, can be used to run the same application itself. So does that answer?
Yes, thank you.
Okay, so let's go on and finish up. So where are we? Okay, Docker images and all. Now, since we have our Docker images, head last 5. Sorry, dead bow. Okay, so now this is the house. We need to, run this image. So a container is the running instance of an image. Now, how do we run a container? Before we do that, let us look at common Docker commands. We've been typing Docker images. Docker images would give you the list of different images. You can also have Docker. If you want to remove an image, Docker rm remove image, then specify the image that you want to remove. We've talked about that. Then another one is Docker ps. Now, what Docker ps will do is that Docker ps is going to list the running containers that you have. Running containers. You can see that right now I don't have any running containers, right? But if you want to list all the containers that have run and have stopped, or to list containers that are running and the ones that have stopped, you just do Docker ps -a. So you can see this is going to list all of the containers that have started and that have stopped. Right now, because I don't have anyone that is running, it's just listing the exited ones. You can see 3 hours ago, 26 hours ago, or what have you, right? So let us go back to Docker ps. Okay, we don't have any running container. Good. So we talk about Docker pull, Docker run. Okay, now let's talk about the concept of Docker run. Now, I love to use illustrations a lot so that you would understand what is going on. Now, once I type Docker run here, let's just say I want to run an image, Nginx image, and then maybe I specify a port. Don't mind what I'm running. Don't mind what I'm running. Just forget that I'm actually running something, right? So Docker run -p, maybe ports 8090 to port 80, Nginx. Sorry, my spelling. Docker. Good. Now, you can see what is happening. This guy has, where is it? Okay, you can see Docker. I'm saying that I want to run an image. I want to run a container from an image. So the command is Docker run. What ports do I want to specify? For example, let's say within my environment, I want to run this Nginx image on another port. Remember that this Nginx image itself is a public image that is not within our image itself. So if you have an image that was built by your friend that you actually want to run from, meaning you don't want to create an image before running that container, you can just go ahead. Just the way I created an image and I sent it to this Docker hub that is here. The same way, I'm sure that anybody that has this, okay, let's even try it. Let's try it on this play with Docker. So Docker run. Let me paste this here. Oh, can I paste? How can I paste it? Docker run. So this is not my environment. This is not like a public environment, but I want to pull this image that we've created, right? Staging web app. what is the tag? Tag is version 2.1. Now, look at what will happen. Do you see what is happening? It is going to this public repo, meaning anybody. In fact, you can just launch labs.playwithdocker.com, just launch it and pull this image that we just built. It will pull it because this is on a public repository. You can see that this is already listening on that port 8080 that we defined. Can you see it? It's already listening on that port 8080 that we defined within this, our Docker file here. So anybody in the world, Australia, Germany, Canada, UK, you can pull this image because I have sent to the public repository here. But the concept I actually want to explain is this. You can see what is happening here. When I told you that Docker run, meaning I want to spin up a container, it should run from that image, from this image. I put Docker run this. Look at what happened. Unable to find image this locally. Pulling from Babalola 05 staging web app on my Docker this thing. Now let me now explain the concepts to you. So I have a shower tap. I have a shower tap here, right? This man wants to use the shower tap. He now connected the shower tap to two reservoirs. Now this reservoir is in his house. Let us put like a dotted line here. This reservoir is in his house. While the second reservoir is in his estate. This one is not in his house, right? By adventure, the water in this reservoir is on this level, while the one in the estate is high enough. By the time this man turns up the tap, right, water is going to be sourced from this first. It's going to be sourced from this reservoir first, right? It will be sourced from this first before going to this other place. Now, per adventure, this person here wants to shower with maybe hot water, right? And the hot water there's no hot water within this particular reservoir itself. But by adventure, there's hot water within this particular reservoir. The man is saying, Mr. Shower, please, I need hot water. Do you know what the shower will do? The shower will first go to his own reservoir to check, is there hot water? No, there's no hot water. Let me go and check outside. Is there hot water? Yes, there's hot water. It will now source the hot water. And then this man is now able to use hot water to bath. Do you understand? So this same concept is what is happening here. By the time you do Docker run the name of an image, if that image is not found locally, it will go outside the repository, which is this public repository that we built here, to go and source for it and then run. That was what happened here. Docker run this. It said unable to find image locally, meaning, okay, there's no hot water here. I can't find the image here. It now went outside to go and find that image there. So what will now happen if I just run, okay, let me create an instance. What will happen if I just run anything? Docker run, let's say Dapo. What will happen? This is what is happening. Unable to find this locally, meaning I have gone here. This might now say, I am looking for very cold water. Shower now went out to the local repository. Is there very cold water here? No. Went out to the estate reservoir. Is there very cold water? No. It's now coming back with an error message. Oga, there is no cold water anywhere. That is what these things signify. Meaning, I've gone locally, I can't find this image, right? And then there is also, I've also gone out and I can't find anything. It's now returning with resource requested access and requested access to the resource is denied, meaning I can't find anything and I won't run. Do you understand? Now, once you get that concept of Docker run, then we'll be good to go. So let us now stop this. Fortunately, I might not be able to stop. Okay, good. So let us now run our application. Remember where we're coming from. Docker images. Where we are coming from. Head 5. Okay, so now let us run this application. So how do we run it? How do we run it? It's just Docker run. Let me give it.
Please, can you clear your screen?
Okay, sorry, let me clear my screen. So how do I run this now? Docker images. Right. So, sorry, images. Or you can still put image ls, either of the two. Either use Docker image ls or Docker images, either of the two. So I want to run this staging app. So Docker run. I want to give it a name. I want to name my container. Right. Let me name my container, let's say daas container. Now, and I want to specify the ports. So this is like you trying to type google.com, right? By the time you run this, you need a port that is going to be accessed externally. A port that is going to be accessed externally. So the port that I want to access externally is, let's say, port 1990 to map to, port 1990 to map to this exposed port that we have here within our application, port 8080, right? What image do I want to run this daas container? So this is Docker run. I need to put name. Okay, it's Docker run. You can specify a name. I'm naming this daas container. I want to expose the port, right, outside of the image. I want to expose the port outside. That is port 1990. Map it to port 8080. This is the internal port. Right. And lastly, I will now specify the image. This is the image over here. Specify the image and what tag? Version 2.1. So once I run this, you can see it is telling me that this is now running just the same message that we got. Remember this message that we got. This is now running on what? Ports 8080. So if I should now go to my server, let me launch my server. So if I do now go to my server and launch, okay, so the name of this server is, I think daas.ng, okay, yep. And I type, what port did we expose outside? We exposed port 1990. You can see, hello, welcome to Docker class. I hope you are enjoying the class well. Do you understand the logic now? But the issue with this is that once this application is running, right, I won't be able to do any other thing. If I try to cancel out, I won't be able to cancel out. And that's because within my Docker run command, I didn't tell the Docker engine I should detach it, meaning just run this thing and let me continue to do what I'm doing. So let me go back and go and stop this container. I have it open here. So let us list the running containers. Remember that command, docker ps. So this is the container that is running now. So I need to first stop it, or if I should remove it, docker rm. You can remove with either the name or you remove with the container ID. Let us try and remove the name and see. You can see it's telling me that you cannot remove a running container. Stop the container before attempting to remove or force remove. So it's telling me that I should stop, docker stop. This time, let me use the container ID. So this might take like 10 seconds for it to stop. That's the default time so that the container itself can gracefully shut down. So it has stopped. If I should go back and refresh this, it won't go. Can you see? This won't go. So let's now run that same. Let me now see. So for me to now remove the container, I can now do docker remove the container ID, and I'm good. If I should do docker ps, nothing will come out. If I should do docker ps, remember this command -a, it will list the exited containers itself. So let us now run that command again. This time, we're going to detach it. So let me clear my screen. Docker images head 5. So let us docker run. So you can put the name. You can give it any name. Let me give it Sanusi container, right? The ports that I want to run outside. Remember, this is this port over here. This port over here. You understand? Let me change the port to, let's say, 90. It can be any port you wish, but that port must not be running somewhere else. Let me say ports 9091, right, to be exposed to these internal ports, right? What image? This same image, this version. But I'm now saying that please run it in a detached mode. It can be before or after the port specification. So when it's in a detached mode, just -d. And once you press enter, you can see the container is running and I can do some other things. So detached mode would help you to, get out of that prompt, and then the Docker container will still be running itself. Do you understand? So let us go back and now check. If I should refresh this 1990, it won't work because nothing is running on that 1990. But if I should do 1991, you can see. So one last thing is, let us change this hello, welcome to Docker class, and then we run that image and we'll be good to go. So let's just go back to our application, server.js. I will edit this, run it to thank you, everybody. Let's do thank you, everyone. And this brings us to the end of this class. See you on Wednesday. Okay, so let's save this guy and run it. Now, what this means is that I will now come here and rebuild the image, because you can see I have saved this. If I should go back and refresh, it will still show me, hello, welcome to Docker class. I hope you're enjoying well. Do you understand? Even if I should stop this, if I should stop that container, you can use the first 3 or the first 4. It doesn't really matter. You don't need to copy everything. You can also use maybe like the first 3 or the first 4. Or I want to stop and remove by force. I can do docker remove -f. So this is going to stop and remove it. If I should do Docker PS, it's not running again. Now let us now go back to rebuild that image, because we've made a modification now, right? We need to rebuild it, but you are not going to be one that will be rebuilding this manually. Do you understand? Your pipeline is going to be doing that. So let us quickly rebuild it. So remember, Docker build minus, I'm tagging it this time around. I will just put Sanusi / let's say test app. I will tag it to maybe version 1.2, right? And that's that. So you can see, because I've changed something within the source file itself, it took like less than 5 seconds to run it itself. So let's do Docker. Let me clear my screen again and do Docker image head 5. You can see the Sanusi app. So let us run this Sanusi app again. What is the command? Docker run. Who is this? Docker run name Sanusi container. Right. I want to expose this time to port 7070. And I need to put it in a detached mode so that it will allow me to do whatever I want to do. Right. And then point to what Sanusi test app and this tag. That's all. So let us go back. And what port did we export? 7070. Oh, okay. Can you see what happened? Who knows what happened? Can anybody tell me?
Yeah, it was not mapped to our internal port, right?
Perfect, perfect. Thank you. So Docker remove -F. Let me remove Sanusi again. And then rerun it. Port what? 8080. So that's that. So once I go and refresh this, you can see it has even refreshed for me automatically. So thank you, everybody. This brings us to the end of this class. See you on Wednesday. All right. Thank you so much. I just needed to kind of like stress on this so that we can have enough time to practice on our own. So if there will be another class, I will let us know. But I think with this information, just rewatch the video again, practice on your own, and you'll be good to go. So next week, we'll be going straight into Kubernetes. So please practice this thing very, very well. So I want to start Kubernetes. It won't be strange. Okay, someone is asking, does the container has an IP address? Yes, it does. That is another concept that we need to look at. So once there's another command called Docker inspect. So you can actually inspect the running container. So just type Docker inspect this. And you can see the IP address. Israel, does this answer? So once you inspect that container, you see the IP address there. So you can, change the host name. So by default, this comes with a default domain name, if I'm not mistaken, or you can actually set your own domain name so that your applications can now be calling each other on that domain name. I think it's somewhere down here, if I'm not mistaken. Yes. Can see domain name. So you can give this thing maybe sanusi.local or sanusi.whatever you want to give it. Another Docker that needs to be calling this our express app, we don't be calling sanusi.local, because if you are calling the container ID directly, the container can go down and come up. And once they go down and come up, right, they lose their Docker ID, but the domain name will still remain. Do you understand? So that will bring us to the end of the class. I hope this was interesting and innovative.
Yeah, very interesting.
Yeah.
Just a quick question. You said something earlier that you teach us how to reduce the size of a particular file.
Oh, yes.
I don't know if you have done that. Yeah. All right.
Oh,
and
yes,
secondly,
yes.
Let me ask the two questions. And the secondly, you performed an instance or an example where we use a particular programming language, for a particular app, Node.js. What of the situation where we have multiple programming language used, maybe Python, Node.js, JavaScript, and all that? How can you be able to specify it when building a Docker file? That has been my issue.
And so the issue with that is like all the programming languages that we have, they have their different Docker files. So you go online, just check for Docker file for Python, Docker file for Node, Docker file for .NET Core. You see all of the best practices, in terms of creating Docker files that you have. Then you can now work, based on the concept that we've done today. Then there's another thing again called what is it called now? Multiple image file itself. So within Docker itself, you can have multiple stages. Within your Docker file itself, you can have multiple stages where you are informing Docker that please, after building this application, before launching it, I need that application to be run within maybe Nginx, right? You can actually do that, but that's like an advanced, way of doing things. So you can always go online. Once I'll get the material for you to actually read on. There are so many things that actually perform with Docker. Once you go online, you can see all the you can see a Docker file that has maybe like 20 or 25 lines, doing different things itself. Do you get? So as per your question, Python, .NET, Java, they all have best practices, using Docker files itself. Does that help?
Yeah, it helps. And thank you. I'm waiting
Then for the one I actually talked about on how to be able to reduce the size of your image, you might not be able to do that now because of our time. But what you have to do is, instead of the from node 16, right? There's something we call Alpine. So an Alpine is just like a miniature of the node image that you have itself. So that one is very, very light and it performs the same function. And the control plane for attack is very, very low as compared to, where you're just pulling node 16. Node 16 has so many high surface area for attack. That is why people will usually, tell you that whatever you want to do, right, use the Alpine version. Meaning, if you want to run this on your own, just within your Docker image file, just type Docker, from node column Alpine. That is going to download. Maybe you can just try that now on that Play with Docker instance.
Yeah. I've seen an Alpine before.
Exactly. So the image will be very, very small and you're able to go.
That's fine.
Does anybody else?
I thought the Docker ignore will enable us reduce that the size.
No. Okay. The Docker ignore is just to specify unnecessary files that you don't want to be copied, files that you want to ignore normally. So with that, you cannot specify it and you'll be good to go. So does that help?
Thank you so much, Dawson. You really did a great work. I appreciate it. Thank you, sir.
Yeah, you are welcome. So if there will be a class on Wednesday, I will let us know. But there will be an assignment for us though, so that at least we can start working on the assignment and we'll be good to go. All right. Sorry. I'm sure Nuruddin and Sean will be so mad at me right now because I've taken like the whole time. So Nuruddin.
I'm here.
Yeah, Nuruddin, Sean. All right. Go ahead.
I think it was a very, very intensive class, and you really touched a lot of things, starting from building image, the basis of Docker, the installation of Docker, up to the necessary Docker command, and we even went to to an extent of explaining some basic information about Node.js and so on. So it's a very good session. However, what I want to tell you is that this is just This is just a fundamental. Docker is a big one. We still have Docker networking. That's another particular part of Docker. There's also security, that's container security. That's another aspect also on its own. So what I will say is that try as much as possible to practice everything. Watch the video. It's a perfect class. Try and watch the videos and After then, it will give you like a good fundamental for you to take in Kubernetes, which is going to be our next class. So that will be all from my end. Thank you so much, Dapo, and thank you everyone for being available. Even though I noticed that the number of participants were reducing at a particular time, I know some of you might have been lost, probably were expecting videos on YouTube. Definitely we get the videos, but still it's important that once we start our classes, please stay in the class from the beginning to the end. It's very, very important. Thank you so much.
Yeah, thank you so much, Nuruddin. Sean, do you have any Sean on the call? Okay, all right, guys, that brings us to the end of the class. The video is going to be made available by noon today, and will also be pasted on our LinkedIn. So please follow us on LinkedIn. Share the news to everybody about this platform. It's free. You don't have to pay any dime. Right? It's free. We're just passionate. We're just passionate about giving back to the community. Like, we're just passionate givers. You understand? So thank you all, and please do have a nice weekend.